student, welcome to my YouTube channel Mathematics Corner. I am Mukul Sarma subject teacher. Today I shall discuss some problem in exercise number 5.1. Last class I have discussed some problem which are in A plus IB form. Today also I discuss one problem. This is question number 10. Expressed in A plus IB form. It is minus 2 minus 1 by 3i whole cube. Solution. We have to recall the cube formula. Here, A minus B whole cube, or we can split it into A plus B whole cube also. If we take A plus B formula, then A will be taken as minus 2 and B will be taken as minus 1 by 3i. Therefore, we have to use A plus B whole cube formula here. A plus B whole cube. A cube, there is a first term cube. First term means minus 2 cube plus second term cube 1 by 3i. This is first term cube, second term A cube. In the formula there is A cube plus B cube plus thrice A square B first term square into second term plus 3 first term into second term square, that is A cube B cube thrice A square B thrice A B square. This is done. Now this is a minus 8. This will be plus cube. There is odd number in the power. Therefore, it is minus 1 by 27. 27. There is I cube plus there is 2 square. This is 4 minus 1 by 3i. 3 can be cancelled, and this is minus 6. This is and 1 by 9 I square. This is minus 8. We know I cube is equal to minus I. Therefore, 1 by 27. This is minus I. Since I cube is equal to minus I. This is minus 4i. This is minus 6 1 by 9. I square means I square is minus 1. Therefore, minus 8 plus 1 by 27i minus 4i. This is plus 6 by 9. Here this is a real and this is real. Even 2 by 3 minus 8 and 2 by 3 are real. Therefore, minus 8 plus 2 by 3. And this is imaginary part. Therefore, I take I as common. 1 by 27 minus 4. This is 3 minus 24 plus 2. This is 27. 1 minus 81. 27 into 4. Oh, no, it is 8. 108. It is. This is minus 22 by 3 plus I. This is minus 107 by 27, which is A plus IB form, which is A plus IB form, where A is equal to minus 2 by 3 and b is equal to minus 107 by 27. This is all about the problem. Next, we'll discuss multiplicative inverse of complex number. That is multiplicative inverse of complex number. Multiplicative inverse. Complex number. Let z is equal to a plus ib a complex number. Then its multiplicative inverse. Multiplicative inverse is denoted by z to the power minus 1 and z to the power minus 1 is equal to a plus ib power minus 1, and this can be written as a plus ib, 1 by a plus ib, and we have to simplify it just 1. Here is a plus ib. We have to write another term a minus ib, so that is it is a plus b and a minus b formula. If there is a plus ib, we have to include a term a minus ib, and this term also can be written in numerator also. That is a plus b, a minus b, this type. Therefore a square minus b, b means ib, b square. This is a minus ib. Therefore a minus ib, this is a square, this is plus b square, because I square is equal to minus 1. Therefore if we write in a plus ib form, this is a by a square, this is I b. Therefore multiplicative inverse of z is equal to a plus ib is a by a square plus b square minus b by a square plus b square. In the exercise there are some problem. Is this question number 11, that is question number 11 given. Find multiplicative inverse. Multiplicative inverse of 4 minus 3i. Solution. Let z is equal to 4 minus 3i. Therefore z to the power minus 1 is equal to 4 minus 3i to the power minus 1. This is the multiplicative inverse. We have to simplify it. This is 1 minus 4i. We cannot write any number including I in the denominator. Therefore we have to remove I from denominator. For this we have to multiply denominator with 4 plus 3i. Since there is 4 minus 3i, we have to multiply is 4 plus 3i, and this term also multiply in the numerator also. That is, we can write is 1 into 4 plus 3i. This is 4 minus 3i, 4 plus 3. And this can be written as 4 plus 3i. This is a minus b, a plus b, a square minus b square formula. This. And this is equal to 4 plus 3i divided by 16 plus 9. Since I square is equal to minus 1, therefore this is 16 plus 9. And this can be written as 4 by 6. We can write it, say, this is we can write it, this is 4 by 16 divided by 4 by 16, 25. It is 4 plus 3i, that is 25. This is 4 plus 3i. It is 4 plus 3i divided by 25. And we can write it 4 by 25 plus I, 3 by 25. This is the multiplicative inverse of 4 minus 3i. Another problem that is about multiplicative inverse, that is find multiplicative inverse of multiplicative inverse of root 5 plus 3i. Solution. Let z is equal to root 5 plus 3i. Therefore, z to the power minus 1, that is multiplicative inverse of z, is equal to root 5 plus 3i. We can write it as root 5 plus 3i. Now we have to remove imaginary part from here. This is, we have to multiply with the denominator 4 plus 3i, that is we have to multiply it root 5 plus minus, this is root 5 minus 3i, so that it is a plus b and a minus b form, and this is to be multiplied in numerator also. Therefore this is root 5 minus 3i. Now this is root 5 minus 3i, and this is a plus b minus b, a square minus b square. And this is root 5 minus 3i. This is 5 minus 9i square. I square means minus 1. Therefore, I square is minus 1. Therefore, 5 plus 9. This is, since I square is equal to minus 1. This is root 5 minus 3i divided by 14. If we write it in the a plus ib form, then root 5 by 14 minus I, 3 by 14. This is the multiplicative. This is the multiplicative inverse of root 5 plus 3i. So this is all about the problem. Next class I shall discuss about conjugate complex number and modulus of complex number.